And one more important disclaimer that the purpose of this event is to speak about the performance testing and how it could be useful for your project. If you have any technical questions, for example, how to use any performance tools or how to implement it, do not hesitate to ask the questions in the discussion panel on the event page, and our speakers will answer them later. And our topic today is Boost You App Performance, Decoding Performance Testing. Vadzim and Hanna will describe this topic today. And my name is Andrei, and I will be a moderator during today's sessions. So if you have any questions related to the topic, please write them into the chat, and Hanna and Vadim will be able to answer them at the end of the presentation. So let's start. Vadim, the floor is yours.
Yep, thank you, Andrei. Hi, everyone. When someone talks about performance testing, you might picture something kind of disconnected from the real world, and that's totally fine. But the next hour should help clear things up about performance testing and why it's important for your project. Hey there once again, I'm Vadim, performance engineer at EPAM Systems. I've got around 6 years of experience in the IT world and nearly 2 years specifically in performance testing. And right next to me is Hanna, the senior performance engineer with 5 years of performance testing expertise. And today's agenda is as follows. First of all, we'll break down what performance testing is all about. After that, we will try to understand why your projects absolutely need performance testing. Then we will discuss those sneaky performance bottlenecks that can trip you up, learn how to conduct performance testing like a pro, and finally, talk about analyzing test results. So stick around and let's get started. And firstly, let's break it down. What is performance testing? Performance testing is all about checking how a system or app handles its job when things get real. I'm talking about when lots of users jump in at once or when it's under heavy load. For example, think about your favorite online shopping site during a big sale. Everyone's rushing to grab those discounts, and sellers are working overtime to keep up with this traffic. And the main deal with performance testing is to see how fast, efficient, and resource-friendly the system is. It helps detect any weak spots, bottlenecks, or limits when we put it through different user situations and loads. So it's like giving your system a stress test to make sure it can handle the heat. Okay, let's dive into why performance testing is crucial for projects. And the first reason is to identify and fix performance issues. Think of performance testing as your system's personal detective. It snoops around, detecting weak links like slow response times, systems using too many resources, and those are all moments when your system can't handle too many users at once. It can handle the heat. And finding and fixing issues early saves developers time, and it's much, much cheaper to fix problems before they reach you in production. The second reason is to ensure user satisfaction. No one likes waiting in line, right? Well, the same goes for a slow system. No one likes a sluggish system. It's a buzzkill for users. So performance testing ensures that users have a smooth, frustration-free experience. The next one is to plan for growth. It's like preparing your ship for more passengers. And with this data in hand, you can plan your resources, allocate them effectively, and ensure your system sails smoothly as more users hop on board. Reason number 4 is to meet expectations. You set the performance bar, and performance testing checks if your system can jump over it. It's like making sure your favorite team meets its winning goals. You get solid data to see if your system is on track to meet your performance targets and keep everyone happy, right? Right. And eventually to optimize resource utilization. Performance testing is like an efficiency expert for your system. It covers those areas where resources like CPU, memory, or network are either working too hard or doing something with minimal effort. And knowing this, developers can fine-tune resource usage, save money, and make your system perform like a champ. So, the general idea, which I'm trying to deliver here, is adding performance testing to projects is like having a secret weapon. It helps organizations understand the system's performance, keep users smiling, save resources, maintain a good rep in the industry, outdo the competition, fine-tune their systems, and reduce risks. In the end, it's the recipe for creating a systems that meet user needs and achieve business goals. I guess you got it. Let's move on. When you're all about boosting performance, you've got to watch out for some common issues that can slow down your system up. Here is a quick list of things to watch out for. And the first one is CPU bound. When your computer's brain or CPU can't keep up, it slows down. It's like a tired runner in a race. The second here is memory bound, and think of your computer's memory like a desk. If it's too messy and full, things get slow. This can be due to memory leaks, messy memory management, or just using too much memory. The next one is disk input-output bound, and imagine your computer as a slow mail delivery person. If it takes forever to deliver or pick up mail, surprise, surprise, it's like a traffic jam for your computer. Network bound is when in systems that depend on the internet, a slow or busy network can slow everything down. It's like a slow highway for your data. The next one is database bottlenecks. And databases can be troublemakers if they're not neat and organized. It's like trying to find things in a messy room. Inefficient queries, missing indexes, fetching too much data can gum up their works. The next one is inefficient algorithms and data structures. Think of this as using a teaspoon to dig a hole. If your software doesn't use the best methods for handling data, especially when there's a lot of it, things slow down. And the last three, contentions and locking, is when tasks fight for the same resources. UI running bottlenecks is your software buttons and menus move slowly. And finally, the last one is lack of caching. Lack of caching is like when you read the same book over and over without a bookmark. Caching is like those bookmarks. It helps your system store and find information faster. So here is the second big idea. To find and fix these speed bumps that slow things down, you've got to get to know your system web really well. This means checking it out, keeping an eye on it, and studying how it works. Once you have the information or details, you can use some tricks like making the code run more smoothly, managing your resources better, using a memory saving trick called caching, or just letting your computer do multiple things at once. And all this jazz can make your system work better and faster. Now that we've got a handle on those typical bottlenecks, the million-dollar question is, can you fix them yourselves without performance engineers? And actually, no. Okay, maybe if you're lucky, but the chances are really low. In fact, chances are you'll probably miss those bottlenecks if you don't bother with any performance testing. And as a result, you mill those on prod. Already met them. So another question then, how on earth do we go about identifying them? And that's where our trusted tool performance testing comes into play, right? There's a set of crucial activities, and we can call it testing game plan. On the slide, we've got activities that performance engineers usually take, but you don't need to know them. And you don't need to pay attention to them at the moment. The entire process can vary from one project to another, and it's a good idea to get consult from a performance engineer. But the second but, let me tell you one small thing. There's one activity that stands out from the rest. It's crucial, fascinating, and somewhat tricky part of what we do. If we put on our detective hats to spot bottlenecks and figure out why they're causing trouble. And I'm talking about analyzing test results. So let's pass the mic and screen to Hanna, and she'll break it down for you. Okay? And as Hanna gets ready for her part, here is a quick question for all of you. Have you ever faced performance issues? Please raise your hand.
Oh, yeah, I see a lot of hands. So I also faced with some H&M issues this Black Friday that we got less than a week ago, and was mobile app and website were unavailable. So yeah, it seems like it's common issues every year, the same. Okay.
Yeah, okay. So, hi everyone. Should I start or continue? Okay, then we'll share with you a couple of real life test cases that we faced on our practice. For sure, performance testing isn't just about running tests. It's also about digging into the results to figure out what's going on. By looking into the test results, we can find and fix problems, make the system work better, and give users a smooth experience. This helps us make smart choices based on the data. All right, let's break it down with some real-life examples. The classic one. Picture a popular online store having a crazy flash sale and lots of people rushing to the site all at once. With the help of performance testing, we can predict if the website can actually handle such sudden rush of customers. Therefore, we've created a test simulating such kind of situation. So we kept adding more and more users to the website until a website could not handle it and things got crashed. We hit a maximum of 1,500 users here, and that's when the system gave up. That's what we call a capacity point. It's like the system breaking point, showing us the maximum it can handle. So after some detective work, we found out the reason of the breakdown or the bottleneck. It turns out that our machines did not have enough resources, especially CPU. It just wasn't enough for all those buyers. The fix here is pretty straightforward. We just need to bump up the resource limits or tweak the auto-scaling settings. And this significantly helped our system to handle the load better. Now, let's dive into the second scenario. While doing load testing, the Azure instance that's running a service is getting shut down because of an error in Java runtime environment. So checking the graphs, it looks like there might be a memory problem. As you can see, the used memory keeps going up even when we reduce the workload. After looking into it, we found the culprit behind the memory leak. It was happening because we've got too many threads that just won't quit. To fix this, we simply need to terminate the threads that are causing the issue. And here you can see how it was done in our way. Now, let's talk about the following case. During performance testing, application crashes due to the Redis cache out of memory. Even though it's supposed to have maximum of 12 gigabytes of memory, it used up to 20. After that, the system crashed and it could not recover because Redis was already out of the game. The solution here is also quite simple. We should set up an eviction policy in Redis to remove old cache and replace it with new one. But later on, we discovered another problem here. While running performance testing on cache, requests that were supposed to be quicker actually turned out to be slower with cache. In fact, it seemed like using the service without the cache was a better option. Something was wrong here, and that's how we resolved this. After some analysis, we realized that we were not bundling our requests to the cache. Instead, we were making individual requests for each item. So we started sending a bunch of items in a single request. And this made Redis much faster, improving its performance significantly. So in the end, here is the third big idea. Performance testing is like a friendly warning bell before the really costly crash. You'd better catch those bugs before they bite you in production. Most likely that you've either already faced them or you are about to. Once more, let's review today 3 key ideas. Firstly, create system that meets user expectations and achieves business goals. Then, beat performance roadblocks to speed up your system. Last one, catch bugs before they find you in production. And of course, you can do all of this using performance testing in your project. With that, we are actually done with our presentation for today. But before we jump to the Q&A, let's address a few questions that we often get asked. Firstly, how often should we do performance testing? The answer is that performance testing frequency depends on several factors, such as your application's complexity, criticality, and how fast it changes. You should test it at various stages, like early development, before big updates, after changes, and also during scaling. It's better to test regularly to ensure consistent performance and automate daily tests for a healthy testing process. Next question. Can performance testing guarantee the best performance? And here, the thing is that performance testing helps to identify and address issues, but it does not ensure perfect performance. It offers valuable insights and aids in optimization, but only constant monitoring and tuning based on real-life usage are essential for optimal performance. And last one, can we do performance testing in the cloud? Yes, certainly you can. Today, cloud platforms provide scalable resources to handle different loads. But also, they make it easy to assess your application performance in realistic cloud scenarios and provide great tools for optimization. So it's never a problem. And that's it for today. Thank you so much for your time. And now feel free to ask any questions if you got them.
Thank you, Anna. Thank you, Vadim, for this presentation. So yeah, we have one question in the chat. Is there anything on Earth better than Jmeter for web app and API testing? How do you feel, guys?
Yeah, there are a lot of options actually, but I guess there is no such thing as the best tool. So tools are being chosen depending on the project, depending on the application, depending on a lot of factors. So there is no like one unique answer for each question, for every question, I mean.
Yeah, but
Yeah.
mostly is the best choice.
Yeah, it seems like it's the most popular tool, and
Yeah, most
Jmeter,
popular.
yeah, was one thing when you hear something about performance testing, you think, oh, okay, it will be tested by within Jmeter. Okay, and yeah, the next question I will ask from the discussion panel that we have on the event page. The question raised by Natalia, how to start load testing for AWS-based applications and how to collect its results.
Okay, maybe I will answer this one. So actually, performance testing in cloud does not really differ significantly from usual performance testing flow. So uh, steps are the same, but the thing that differs is usually the tools. Most of the tools, like for monitoring, analysis, and so on. And also there is some specific cloud features like scaling, for example, that like you won't face in the usual situation in other scenarios, not cloud.
Okay,
But
we have, yeah, seems like we have Natalia on the call. Natalia, do you have any additional maybe topics for this particular question, or
Yeah,
we covered?
yeah. Do you have a list of tools to look at to start testing, load testing of AWS-based applications to start with?
You mean AWS tools, like inner tools or something else?
Like, I need to perform load testing of AWS application, which, for example, sends some request into SQS and then perform some like requests are coming through SQS, and then our application makes some magic. And what tools can I look at to start load testing on my project?
Maybe we can get back to this question by text because it's like some technical stuff. So list of tools can be very, I guess, everything depends on the project, but so there is a lot, big variety of tools to choose. So we can answer it by text, I guess.
Okay, yeah, if you don't mind, Hanna, could you provide some examples in the discussion panel later?
Yeah, sure.
Okay, and the next question is also by Natalia, how to calculate the target load for testing based on production peaks?
Yeah, I can answer that. And I will answer about the whole scenarios. And usually we create scenarios which simulate user actions on production. And at the same time, we consider business critical features such as checkout page, login page, and so on. And then we prioritize them based on critical user passes. For example, high traffic features. And answer for that question about which load should we do and how many requests we will make depends on your peak activities on production. So the answer is yes, peak loads on production.
So like if I know that our production peak is 5,000 requests at once, for example, based on that, how to calculate the target load for testing on lower environments and also in production. Does it need to be the same or need to include some growth for future?
What do you mean by lower environments? You mean that
Like
they are
test.
not the same, like not production like, but like
Yes.
scale down, right? Yeah, but usually in this case, of course, you cannot create the same level of load as for production. In this case, you can try scaling down this load, but it won't be like if the environment is 2 times weaker, so you choose like 2 times lower level of load. You should make some experiments to understand how it's being scaled, and then make some predictions, some analysis, and so on. But if you have this peak number, like 500 user requests or something like this, for sure you should try to guarantee that production will handle this level of load, even if it will be not peak, but like some several period of time.
Yes, thank you. If you could provide any resources to look through on these topics, that will be very beneficial. Thank you.
Okay, we'll look into it. Thanks.
Yeah, thank you, Natalia, for your questions. And one more question. Can performance testing be done by developers or by QA engineers?
Yeah, they definitely can, but can you guarantee quality of this work? Also, it's not only about scripting and conducting tests. There is a bunch of activities to take before testing, lots of activities after testing, and we do all of this to make system high performant, right? So at least you may ask consultation from seniors performance engineers. But the answer is yes, they definitely can.
Okay, that's very interesting part because it's part of responsibilities, and if we take this, yeah, we need to be sure that we do the right stuff. Okay, that's it regarding the discussion panel. So if you have any additional questions, maybe it's the right time to ask them. Okay, 30 seconds for a question, and if no, we will finish. Okay, no questions. So yeah, Vadzim, Hanna, one more thank you for your time, for your preparation for this presentation. And also we appreciate the audience for watching and for your questions. So yeah, please leave your feedback on the community page. Say thank you by providing badges for our speakers and join our testing community. So yeah, thank you for attending. Have a good day.
Thank you so much, guys.
Thank you. Yeah. Have a nice day.
Thank you.
Bye bye.
Oh yeah,
Bye.
so nice animation. Yeah, thank you. Bye bye.